Welcome to the video solutions of CodeDrift. Hi everyone, so today in this video I will be discussing the problem left or right. So the problem says that given a permutation of size n and in integer array a, for each number find if the value of its magic number is greater than or equal to 0 or negative. The value of magic number is defined as count of smaller numbers to the left into count of smaller numbers to the right minus count of larger numbers to the left into count of larger numbers to the right. Return an array where answer of I is 1 if the magic number is greater than or equal to 0 or minus 1 if it is negative. For example, let us consider this example. So here we are given a permutation of 5 integers 5, 2, 3, 4, 1 like this. So we need to calculate whether some index like some number is magic value is greater than or equal to 0 or not. So let us consider the various indexes, so like the 0th element, then 1th, then 2th, 3rd and 4th element. Okay, so if you consider the 0th element, which is 5, so how many elements are to the left of it that are smaller than 5? So basically there are 0 of them, multiplied by how many elements are to the right of 5 and smaller than 5. So there are 4 elements which are smaller than 5 to its right. So 0 multiplied by 4 minus how many elements to 5's right are greater than 5. So there are none of them, multiplied by how many elements are there to the right of 5 and also greater than 5. So there is 0 of them, so into 0. So 0 into 4 minus 0 into 0 is basically 0. Similarly, you find it for the 1th index element, that is 2. So there is no element to the left of 2 which is to the left of this 2 which is lesser than 2. So 0 multiplied by how many elements are to the right of 2 and smaller than 2? There is only one element, 1, minus how many elements are to the left of 2 which is greater than 2? So it is 1, multiplied by how many elements are to the right of 2 and greater than 2? So there are 2 of them, 3 and 4. So 0 multiplied by 1 minus 1 into 2 is basically minus 2. Similarly, you can calculate it for 2, you will get 0, for 3 you will get 2, and for 4 you will get 0. Okay, so these will be the magic values or the magic number for various elements. Okay, so corresponding to it, what will be your answer array that you need to return? So as you can see, for the 0th index element, the magic number is coming out to be 0. So for this you will have 1. In the second element, that is the 1th element, you are getting minus 2. Since it is negative, you will return minus 1 for this. Here again you will return 1. Here it is 2, 1, and here it is 0. So you will return 1. Sorry, 1. So let us try to see an optimal approach for solving. So how we do? So let us try to think upon this question, that how do we find the count of smaller elements to the left? Okay, can we do it in order of n square or like something lesser than that? Can we do it in a time complexity lesser than order of n? We are trying to check now whether we can do it in time complexity lesser than order of n or not. Maybe order of log n or square root of n, or maybe order of 1. We are now trying to investigate whether we can do the same thing, that is finding how many elements are smaller than the given element and lies to the left of it, or maybe how many elements are greater than the current number and lies to the left of it. How we can do this, if we can do this in order of n or not. Okay, so whether we can do this or not, we are trying to investigate it. So the answer for this is yes, we can do this by using either Fenwick tree or segment tree. Okay, so for solving this problem for full points, Fenwick tree and segment tree are kind of prerequisite. Like you can solve it with either this one or this one. Okay, you should know either Fenwick tree or segment tree, and for your knowledge, it is range query data structure. So both of these are basically used for querying for over a given range. So you can query the sum or query over its product like that. Okay, so segment tree is a more versatile. Using Fenwick tree, you can only compute something over its prefixes, and you can do it over ranges as well, but for that the like you can only do it over ranges for calculating things like sums. Okay, but with segment tree you can find the range maximum, range minimum, range sum, anything. So this segment tree is a kind of range query data structure. Okay, so in my current solution we will be discussing segment tree approach for solving this one, although you can also use Fenwick tree to solve the same, right? So let us try to use segment tree to find our answer. So let us consider this examples. This is the very first example that we had taken. So what we will do, we will build a segment tree on this array. Okay, so what this segment tree will store, basically each node of this segment tree will store how many elements are there in the range L to R. For example, if you consider this node, the value of this node is 0, which indicates that there are no element in the range 1 to 5. So initially we are saying that in every range the number of element is 0. Now we iterate from left to right on this array. So let us say we are at this element. So the value of this element is 5. So we need to find how many elements are there which are lying to the left of this element and are lesser than 5. So effectively what we want to calculate is the number of elements in the range 1 to 4. Okay, so the range 1 to 4 can be broken as 1 to 3 plus 4 to 4. Okay, so you can break your range from 1 to 4 as 1 to 3 plus 4 to 4, right? Now as you can see, there are no elements in the range 1 to 3 plus there are 0 elements in the range 4 to 4. So overall the number of elements in the range 1 to 4 is 0. It means the number of elements which are lesser than 5 lying to the left of it is 0. So let's call it smaller to the left as SL. So the value of SL in this case comes out to be 0. Okay, now you know that in total there will be 4 elements which will be lesser than 5, out of which 0 elements are to the left of it. So the remaining, which is 4 minus 0, must lie to the right of it. So smaller to the right will become total number of smaller elements of 5, that is 4, minus SL. So this will become 4 minus 0, that is 4. Okay, so in this way we find the small number of smaller elements to the left and number of smaller elements to the right. Now let us try to find number of smaller elements to the right. Okay, oh sorry, number of greater elements to the right. Okay, so the number of greater elements to the left. Okay, since we are traversing the array from left to right. Okay, now the number of greater elements, so how many elements are greater than 5 we need to count. So any number greater than 5 must be at least 6. So we will try to find the number of elements lying in the range 6 to 5. But since this is empty subarray or like empty range, so the number of elements in this range will always be 0. Okay, so we will say what? We will say that the number of elements in the range 6 to 5 is 0, which which means the number of elements greater than 5 to the left is 0. So number of elements greater than 5 lying to the right will be equal to the total number of elements which will be greater than 5. So obviously there are 0 of them minus this GL, that is 0. So this also comes out to be 0. Okay, so in this way we can find all these 4 terms, and after finding all these 4 terms we can simply calculate the magic number as SL into SR minus GL into GR. Okay, so by finding this we can simply compare whether this is greater than or equal to 0 or lesser than 0. Okay, now once we find this, we will now update the value of the range 5 to 5, because we have obviously encountered one element which has a value equal to 5. Okay, so we will simply increment the value of this one by 1. So the value of this range or this node will become 1, since there is one element in the range 5 to 5. So if it is 1, then this will also become incremented by 1, and this also get incremented by 1. Okay, so next we move to the next element, which is 2. So we again try to find what will be the SL. So SL will be the number of elements in the range 1 to 1. Okay, now as you can see, the number of elements in the range 1 to 1 is 0, so it will remain 0. The number of elements to the right and smaller than it will then become total number of elements smaller than 2, that is 1. 1 minus SL, so 1 minus 0 comes out to be 1 only. So this will become equal to 1. Okay, similarly we will try to find greater to the left. So greater to the left will be equal to the number of elements lying in the range 3 to 5. Okay, now the range 3 to 5 can be decomposed as 3 to 3 plus 4 to 5. So if you see, 3 to 3 plus 4 to 5 is 0 plus 1 is 1. So it means greater elements to the left will be equal to 1. Okay, so this will change to 1. So the number of elements greater and lying to the right will become total number of greater elements than 2, that is equal to 3. 3 minus 1. So 3 minus 1 will become equal to 2. Okay, 2. So in this way you can calculate again its magic number and finally correspondingly 1 or minus 1 that you need to return. After that you will simply update the range 2 to 2, since there is one element lying in that range. So this will get updated by incrementing it by 1. So it becomes 1. If this is 1, then this will also get updated or increased by 1. Similarly this will also get increased by 1, and this will ultimately also get incremented by 1. So this becomes 2 now. Okay, similarly then you go to 3. Again try to find the number of smaller elements to the left as the number of elements lying in the range 1 to 2. Again you can see there is only one element, so you will say this will become 1. Then SR will become total number of smaller elements, that is 2 minus SL. So 2 minus 1 becomes equal to 1. Again you find the number of greater elements to the left as the number of elements lying in the range 4 to 5. So as you can see there is one element lying in the range 4 to 5. So GL become 1, and GR is like total number of greater elements than 3, that is 2. 2 minus this GL, that is 1. So 2 minus 1 will become 1. So in this way you can just do it, like after finding it you again update the value of 3. So the value of this node gets updated to 1, and hence this get also updated by increasing it by 1, and this will also get updated to 3. Okay, so in this way you can just keep on finding this over all the elements of the array, and in this way you can do it. Now as you can see, whenever you update some node you only update at max log n nodes. Okay, like if you update this leaf node, then you update all the nodes which lie in a simple path from this leaf node to this root, to the root of this tree. So as there can be at most, the height of the tree can be at most log n, so updation will take log n time. Okay, similarly querying will also take log n time. This is a very general fact that querying and updating in a segment tree takes order of log n time. Now coming to the time complexity, the time complexity of this approach is order of log n, because segment tree, whether you update or query over segment tree, both of it takes order of log n times. Since you are doing it for all the n elements, the total time complexity will be order of n log n. Okay, the total space complexity will be order of n. Okay, the extra space complexity will also be order of n. And one important thing, that whenever you build a segment tree on n elements, basically you require order of 4 times n space. Okay, so like yeah, you can say it's order of n, but actually it's order of 4n, because you need 4 times the size of the array, okay, that you need to create. For example, here although the number of elements here is 5, but if you see how many nodes are there, so you count it 1 2 3 4 5 6 7 8 9. So obviously you can see the number of nodes in created in the segment tree is not the same as number of elements in the array. So obviously it's somewhat greater than it. So it is said that the maximum number of nodes in a segment tree won't exceed 4 times n. So you can say that you need an order of space of 4 times n, or asymptotically order of n. So I hope it was clear to you. Thank you for watching. So thank you for watching, and please like, share and subscribe our channel.